Hi guys, I welcome you all to my YouTube channel. So in this video I am going to discuss two important questions from your subject thermodynamics. Okay, so the first question is what is the value of slope for the process PV square is equal to constant on the PV diagram for an ideal gas. Okay, so if we see PV diagram, suppose this is P, this is V, this is known as isobaric process. So here P is equal to constant, and in this process here V is equal to constant, and in this process PV is equal to constant, right? These all are PV diagram. Okay, and for PV square is equal to constant, it is almost like same only, just something slope is something different. PV square is equal to constant. Okay, but without drawing this diagram also we can solve this question. Let us solve this question. Solution. It is a simple problem but important. Okay, so given PV square is equal to constant, now we can write P is equal to C by V square, right? Or we can write C into V to the power minus 2. Yes or no? Right? So in the question, as we are asked to find the slope in the PV diagram, so differentiating P with respect to V. Okay, so dP by dV is equal to, as C is constant, it is constant. Okay, now if we differentiation of ddV of V to the power minus 2, it is simply minus 2 1 by V cube. Okay, so minus 2 by V cube is the differentiation of V with respect to V. Okay, now what is the value of C? C is constant, means PV square, right? So we can replace PV square into minus 2 divided by V cube. So if you simplify this V square will cancel 1 of V, so it will be minus 2P by V. This is the answer. Okay. Okay, so the solution for the first question is found to be minus 2P by V. Okay, so this is the final answer. Now let me discuss the second question. The second question says a series of combination of two Carnot engines operate between temperature limit of 180 degrees centigrade and 20 degrees centigrade. If the engine produces equal amount of work, okay, equal amount of work, this is important, then intermediate temperature is how much, and you are asked to find in Kelvin. So let me draw the diagram quickly. So this is one engine, suppose E1, and this is under engine E2, and this is producing work, this is also producing work, and temperature limit is 180 degrees centigrade and 20 degrees centigrade. Obviously engine will produce work when heat will flow from high temperature to low temperature. So this is the flow diagram, and this will be 180 degrees centigrade and this is 20 degrees centigrade. Now see, the equal amount of work is producing by the two engine. Okay, so important point is here in shortcut. Okay, I am telling you the shortcut. So if work is equal for both the engine, then this intermediate temperature, suppose T, intermediate temperature T will be equal to T higher plus T lower divided by 2. So what is T higher? T higher is 180 degree centigrade. What is T lower? That is 20 degree centigrade. But you are asked to find in Kelvin. So I have to add 270 degree to make it Kelvin. 270 degree, and it is also 273 plus 273 degree. So it will be your 293 Kelvin, right? So it is your 293 Kelvin, and it will be finally 453 Kelvin. Okay, so final answer will be your 453 plus 293 divided by 2. Okay, so after solving you can get the final answer. Okay, so if you solve it, it will give you answer 373 Kelvin. Okay, so intermediate temperature is found to be 373 Kelvin when both the engine will produce same amount of work. But if it is asked to find the intermediate temperature for equal amount of efficiency, so let me rub it so you can write in your notebook. See here, for same amount of work done, the intermediate temperature will be mean temperature of the high temperature and low temperature. Mean temperature, that is T higher plus T lower by 2, that is 373 Kelvin. Now one extra point, suppose in the question you are given that the efficiencies of both the engines are same, then what will you do? Suppose this is work 1, work done is different, but efficiency of both the engine is same. Efficiency of both the engine is same. For same efficiency, in the question it is asked to find for same work. This is not related to your question. For same efficiency, intermediate temperature will be geometric mean of T higher and T lower. Remember, okay, so square root of your 453 into how much? 293. Answer will be in Kelvin. So let me calculate. 453 into your 293, right? So it will be 364 point how much? 32 Kelvin. Okay, so this is one important question. Generally you can see in examination like GATE or anything SSC. For equal amount of work it will be mean temperature, and your for equal amount of efficiency it will be your geometric mean of T higher and T lower. But remember, this asked in Kelvin, so don't do using this centigrade value. If you do it using centigrade value, you will be having one different answer and you will be having negative mark in competitive exam. Okay, so that's all for today. Thank you for watching.